In this video, I'm going to go over part 2 of the mock geometry EOC, the 5th one that we took. So first of all, number 1 says, according to Cavaliers' principle, the cross-sectional area of the two prisms is the same for every height above the base, then the volumes will be the same. Which shape represents the cross-sectional view of these prisms? So what we need to do is think of if we cut this someplace, what is going to produce the same shape everywhere? Obviously, that's going to be the pentagon. Now, I also want to remind you guys that when we're talking about Cavaliers' principle, it basically tells us that if the two shapes have the same base and they're the same height, then they are the same volume. So if you don't remember what Cavaliers' principle is, you need to write it down. If the two shapes have the same area of the base and they are the same height, they have the same volume. So again, the answer was this one up here, A. This next one here says, the resulting triangle RST prime is an example of what kind of transformation? This one is a reflection across the y-axis. So when we look at this one, you should be able to see that T reflects, it's 1 point away from the y-axis, S is 3 and S prime is 3, and again R is 3 and R prime is 3. So that's what tells us this is a reflection across the y-axis. So that was this answer right here. Now this next problem, number 3, when we talk about this problem, it's asking us, a wildlife organization wants to fence off an area of the beach. The organization can only fence 1,000 yards squared. What length X and width Y should the organization use to use the least amount of fencing as possible? So on this one, we need to look at an equation. If we try to find an equation for the area, it would be X. Sorry about that. It would be X times Y equals 1,000. And if we wanted to find an equation for the fenced area, that would be X plus 2Y. So we could put those equations into our calculator and find the minimum where those two intersect. But to me, this problem is a little bit easier just by plugging in the answers that are given to us in this problem. So what I'm going to do here is I'm just going to go ahead and find out if I do 50 plus 2 times 20 is 40, that's 90. And again, 40 times plus 2 times 25, that's 50, that's also 90. Then we're going to do 45 plus 2 times 22 and 2/9 would be 44 and 4/9. So that's going to be 89 and 4/9. And then our last one is going to be 55 plus 36. That's 2 times 18 is 36, and 2 times 2/11 is 4/11. So this one is going to be 91 and 4/11. So it's asking us which one uses the least amount of fencing, and that would be answer C right here. And to me, this is the easiest way to solve this problem because I can easily figure out what the answer is. Now, there are other ways to solve it, but sometimes we need to use test-taking techniques, and this is a test-taking technique to plug the answers back in and see which one makes the statement that we want. Number 4 says, find the area of the polygon defined by the coordinates 0, -5, -5, 0, -5, -20, and -20, -15. Now, I plotted these points, and when I plotted these points, I came up with a coordinate plane of that graph. So this is the graph I came up with after I plotted the points. And this is important because this is going to help us figure out what are our opposite sides here. Now, my guesstimate is that this is a rectangle, pretty much looks like a rectangle. Now, the way I could verify that is to compare the diagonals. And if the diagonals are congruent, which they do turn out to be congruent, then this is a rectangle. So what I'm going to do, though, is I'm going to jump right into solving for opposite sides. So I'm going to go ahead and find the length of this side right here. So that's going to be -5 plus 0 squared plus 0 plus 5, and that's a plus 5 because it's minus a minus 5. So this is going to be 5 squared plus 5 squared. So this is going to be the square root of 25 plus 25, so that's going to be the square root of 50. So that's this side right here, the square root of 50. So now we need to find our other side, this one right here. So that's what we're going to do next. So to do that, I'm going to do, again, 0 minus minus 15 would be plus 15 squared plus negative 5 plus 20. Again, it's minus minus 20, so that's why it's plus 20. So this is going to be 15 squared plus 15 squared. Going to take the square root of that. That's 225 plus 225. Still taking the square root of it. That's going to be the square root of 450. So that's what this length is, the square root of 450. Now to find the length, the area of that, we're just going to multiply the square root of 50 times the square root of 450. We can do that actually in our calculator, and when we do that, we get the answer of the square root of 50 square units. So number 5 says a hiker is lost in the woods. A search team has created a coordinate grid to represent the woods. Each unit on the grid is a square mile. The hiker was last seen at 5,10, and we could have walked 12 miles in any direction since he could have walked 12 miles in any direction since then. Which equation represents the area the hiker could be in? Well, I immediately notice when I look at these equations that these are equations of a circle. So I'm going to assume that this is our center and this is our radius. And the formula we're going to use here is x minus h squared plus y minus k squared equals r squared, where h and k are our 5 and our 10, and 12 is our r. So we plug those in, and when we plug those in, we realize that our equation is A. Number 6 says the circumference of a circular base of a cylinder is doubled. How does the volume of the cylinder change? So let's go ahead and draw a cylinder with a circular base. And then it says that this doubles. So let's just say it doubles. So that means that the base itself became twice as big, but the height did not. So we're talking about an area down here. So if the circumference, that's the area, the distance around it, got twice as big, then we know that the volume of the base got twice as big, but the height didn't get any bigger. So when we talk about this, we look at this doubled word here. Again, we talked about this yesterday. 2 squared is equal to 4, and we're squaring it because it literally only has to do with the base, and the base is an area. Now, if we talked about the base and the height doubling, then we would do 2 to the third, and the answer would be that the volume is 8 times larger. So the actual answer here is letter C. So this problem says quadrilateral PQRS is inscribed in a circle as shown. Which statement is true? So first of all, it says the measure of angle P is equal to the measure of arc QRS. The measure of angle P, this is angle P right here, is equal to arc QRS. Well, we know that's not true because that angle is half the arc. So then let's go on to letter B. The measure of angle P is equal to the measure of arc QRS. Again, that's not true. So number 3, the measure of angle P is equal to half the measure of arc QRS. That's true. And the measure of R, let's look at R. There's angle R, is equal to half the measure of SPQ. That's true also. And then it says, so angles P and R are supplementary. And we know that that's true too because P and R are opposite angles, and opposite angles are supplementary in a quadrilateral that's inscribed inside a circle. So that one's good. The last one, if you notice this word complementary, that's not true either because of that word complementary. Number 8 says a square pyramid is sliced through the top vertex by a plane. What is the shape of the resulting two-dimensional figure? So, as is typical of me, I'm going to draw this, my pyramid. Okay, so there's my pyramid. And with this pyramid, if I were to cut down through the top, so that means I'm cutting straight down this way, I would get this shape right here, or this shape right here, or this shape right back here, or the side shape, depending on which one. And all four of those shapes are triangles. Now, if it asks about a horizontal, then I would obviously get a square. So you need to make sure you read the question carefully to determine what the question is actually asking you with these types of questions. So the next one, number 9, asks us, by which rule are these triangles congruent? So if you notice here, we have angle H is congruent with angle G, and we have HC is congruent with GC. The one thing that's not marked on this drawing that could be is that the vertical angles are congruent. So if the vertical angles are congruent, then we should see that we have, and I'm going to go ahead and mark this with 2 arcs because it's not the same measure. Then we have angle, side, angle right here. And that is the answer. Down here, it's letter B. Okay, so number 10. This one is 2 chords intersect at point E. According to the diagram, which pair of numbers could represent the lengths of segments CE and DE? So if you remember our formula for this one, let's go ahead and label this 6 and 4 here. And our formula was part times part equals part times part. Sorry. So that means that this is 6 times 4, which is 24. So we're looking for the other product down here of A, B, C, or D that equals 24, and that would be D, because 3 times 8 is 24. So before I answer the next question, I'd like to do a little review on this drawing. So I want to ask y'all, what do we call angles 1 and 6? 1 and 6, we call those vertical angles, right? And vertical angles are, good if I could write, 1 and 6 are vertical angles, and they're congruent. Then I'd like to know what kind of relationship is between angle 1 and 2. So if I talk about 1 and 2, we say these are a linear pair, and these are supplementary. Okay, now let's talk about angles 1, angle 1 and angle 3. Whoops, this thing's not going to cooperate with me. So let me try a different color. I never know when it's going to work and when it's not going to work. So blue, for some reason, has issues. So this one right here, 3. So those are what we call 1 and 3. We call corresponding. And again, these are congruent. Then let's talk about 1 and 14. 1 and 14 we call alternate exterior angles, and these are congruent. Now let's talk about 5 and 10. These are alternate interior angles, and they're congruent. And the last pair I'd like to talk about is this pair right here, 6 and 10. 6 and 10 are same side interior angles, and these two are supplementary. Now what I like to tell you guys is that when the angles are the same shape, they're going to be congruent. If one's acute and one's obtuse, then obviously they can't be congruent. They have to be supplementary. So that was just a little bit of review over all the different types of angles. So number 11 says, given that angle 8 and angle 16 are congruent, 8 and 16 are congruent, what can we say, what lines are going to be parallel because 8 and 16 are congruent? Well, there's only two lines that could be parallel that they cross, and that would be R and S. Because those arcs, those angles don't even touch line P, so it couldn't be P and Q. Number 12 says if the central angle theta of a circle that subtends an intercepted arc is measured in degrees, then the constant of proportionality for any angle in the formula to determine the area of that circle would be which of these? Okay, so this is like talking about a central angle here, and it's being subtended by this. This would be our theta. So that formula that we use to find that, wouldn't that be pi r squared theta over 360? It would be. Now, the question that's really being asked of us here is what is the constant of proportionality? Okay, so constant of proportionality, what that means is what part of that formula never changes, because it's the constant part, right? What part never changes? Well, obviously the r squared and the theta change, so the only part that never changes is pi over 360. So that's the answer, because that's the constant of proportionality. That's what never changes in that formula. Number 13 says a kite is flying 70 feet above the ground and it's attached to a string tied to a stake on the ground. The angle of elevation formed by the string and the ground is 40. Find the length of the string to the nearest foot. So we know that we're looking for this right here, the length of the string. So that's our x. And then what I want to do is I want to look at how does that angle relate to the 70 feet and to the x. So I know that this is the opposite side, so that is going to be O. And I know that this is the hypotenuse because it's opposite the right angle. So the ratio that uses opposite and hypotenuse is sine. So I'm going to say the sine of 40 degrees is equal to the opposite over the hypotenuse. And recall when we have an x in the denominator that we swap that with what's on the other side of the equal sign. So it's going to be x is equal to 40 divided by the sine, 70, I said that wrong, 70 divided by the sine of 40. And make sure again that your calculator is in degree mode. And you want to make sure you do this before you even get started on the EOC. Make sure your calculator is in degree mode. And the answer when we do this in our calculator is 109 feet. So our next problem says construct a perpendicular line through a point that's not on a line. This is represented by which construction shown here? Well, I'm going to go through these and look at them. So the first one is copying a triangle. That's definitely not it. The second one's, this one down here is copying an angle. This one right here, we should, letter D, we should all know by now. This is bisecting. It's a perpendicular bisector. We've been over that one and over that one. So our answer obviously has to be B because it's the only one that's left. And if you notice, we got the point up here. That's the point off line. We would have created an arc down here, and then from those two arcs, we would go arc, arc from there, and from here. So the answer to this one is B. And we use deductive reasoning to find that. So we just basically eliminated the answers that we knew couldn't be correct. And that's, again, another good testing strategy for some questions. Not all, but definitely some. All right, so our next question down here, number 15, is if angle A is 95 degrees and angle B is 105 degrees, what's D? So angle A is 95 here, and angle B was 105, and it's asking us what is this D down here? So again, you should recall that opposite angles in an inscribed quadrilateral are supplementary. So all we have to do here is 180 minus 105, that's 75 degrees. So the answer was A. Number 16 says a 12-ounce can is 5 inches tall and 2.5 inches across. How much soda can it hold if it's completely full? Round your answer to the nearest tenth of a cubic inch, okay? So on this one, we've got a can of soda that is 5 inches tall and it's 2.5 inches across. Now, we don't use a diameter, but we do use a radius. And so if we have the diameter, we're going to do 2.5 divided by 2, and that gets us 1.25. So the formula for the volume is pi r squared h. So we're going to do pi times 1.25 squared times our height. And when we do that, we get 24.5 cubic inches of soda. Number 17 says, after extending the width of the compass to approximately 2/3 of the line segment, what is the next step in constructing a segment's perpendicular bisector? This one is draw an arc above and below the line, and that's because we have our segment here. We measure 2/3 of the way, and then we do an arc here and an arc here. We would pick it up, move to the other side, create another arc, and then we would draw a line through those two. Yes, that wasn't very straight, but y'all get my drift. Again, y'all can watch the videos from Unit 5 if you want to look at the constructions to refresh your memory on them, and that might be a good idea for you guys. Number 18 says, calculate the area of the circle with a radius of 2 centimeters and a circle with a radius of 4 centimeters. Leave your answers in terms of pi. So our formula here is pi r squared. So we're going to do pi times 2 squared, which is equal to 4 pi. And then we're going to do pi times 4 squared, which is equal to 16 pi. Then it goes on to ask us, when the radius doubles, does the area of the circle double? Well, first of all, I know that A is not an answer, and I know that D is not an answer because those are the wrong values. So, and the answer to that question is no. What happened when we doubled the radius was it quadrupled. It didn't double. So this is our answer right here to that problem. Number 19 says, which equation can be used to find the measure of angle C? And then to the nearest degree, what is the measure of angle A? Angle A. So this is a two-part question. We got to answer each part. So we're looking for angle C here first, which formula. Now I noticed that all of them have sine in them, so I'm going to look at using sine. So the sine of angle C is equal to opposite over hypotenuse, and this is my opposite 2, and then the hypotenuse obviously is square. So we're going to do this 2 over the square root of 29. Now if I'm trying to find the measure of that angle, I have to take the inverse of sine and then do it of 2 over 29. And when I do that, I get that the measure of that angle was 21 point change, so it's 22 degrees. So this one's 22. Well, that's not what the problem's asking me. It asked me about angle A. So to find angle A, I'm just going to subtract 22 from 90, and that's 68 degrees. So, first of all, I can eliminate A and C because, again, they have 5s in them, and I don't have any 5s in my problem. And then what we're looking for is the formula like this, and that would just be multiplying by the square root of 29 on each side and getting the 2 to the right, and then the answer is 68, so this was our answer. So for 1, 2, and 3 here, we're just going to move the answers into the blanks once we find them. So number 1 says the roof of Mr. Thompson's house is blank feet high. To climb on top of his house, he leans a 13-foot ladder. So he's leaning a 13-foot ladder across, on the house against the roof of the house and places the base of the ladder 5 feet from the house. So on this one, we're just going to use Pythagorean's theorem. A squared plus B squared equals C squared. And I'm just going to call that A. So x squared plus 5 squared equals 13 squared. So that's going to be x squared plus 25 equals 169. X squared is equal to 144. And if we take the square root of both of those, that's going to give us 12. So notice that I drew a drawing because it helped me to solve the problem. So let's look at the next one. There is a rope running from the top of a flagpole to a hook on the ground. The flagpole is 9 meters tall. The hook is 12 meters from its base. So this time we have A squared and B squared. So we're going to do 9 squared plus 12 squared and figure out what that's equal to. That's 81 plus 144. That's going to be our length over here, x squared. So that's going to be 225 is equal to x squared. When we take the square root of 225, This one is 15. And again, we would drag and drop those where they go. Then the last one, 2 boats leave a dock. One heads north, the other heads east. So we got a boat that heads north. Whoops. Okay. Let's see if I can get this to move back up where it was. Right there. Okay. So we got a boat that heads north and a boat that heads east. So the 2 boats are 20 miles apart. So that means this right here is going to be 20. The northbound boat traveled, we don't know how far, and the eastbound boat traveled 12. So here again, we're going to do 20 squared, that's our hypotenuse, is equal to 12 squared plus, and we'll make this x over here, x squared. So we got 400 equals 144 plus x squared. We're going to subtract 144 from both sides. That gives us 256 equals x squared. Take the square root of the 256, and our answer is 16. So with this next problem, it's a constructed response question. So it says Larry has a circular area in his backyard where he is doing some landscaping design. Determine the areas of the 4 sections in the diagram and show your work. That's part A. Part B is if Larry had 50 square feet of mulch, 20 of sod, 18 of flowers, and 42 of pavers, where should he place each one to minimize his waste? And then part C is shade the diagram to show where each should be placed. Mulch, orange, grass, green, flowers, pink, and pavers, black, okay? So the first thing we need to do is find what each of these are. So what I'm going to do is we're going to use the formula pi r squared theta over 360 for each of these sections. So when we do that with the first one, we're going to say pi, and we've got our radius is right here, so that's going to be 6 squared times 145 over 360. And let me find my sheet here that has my work on it. Hang on a second. Okay, so for this one, we're going to get 45.55 feet squared. Then we're going to do, I'm going to do the 60 next. So this one again is going to be pi 6 squared times 60 over 360. And when I do that, I get 18.85. I'm going to keep moving around my circle, and I'm going to do the 45. So again, this is going to be pi times 6 squared times 45 divided by 360. This one's going to be 14.14. Again, all these are going to be feet squared, just not putting that there. Our last one is going to be the same thing, pi 6 squared times 110 divided by 360. And this one is 34.56. Okay, so that was the first part. We had to have this in our answers. These as part of our answers for the first question for part A. Part B says if Larry had 50 square feet of mulch, 20 square feet of sod, 18 square feet of flowers, and 42 square feet of pavers, where should he place each one to minimize his waste? So what we're looking for is the numbers that are closest to these. So if we have 50 square feet of mulch, then we're talking about this right here is going to be our mulch. Sorry about that. Why? I don't understand why this does that. Every time, y'all. I don't get it. All right, so I'm going to put it, I'll just put it in green over here. So this is mulch. And then the next one has to do with, okay, so 20 square feet of sod. This is the one that's sod, or we could call it grass. Either way, it's same thing. Closest to 20, right? Then we have 18 square feet of flowers. Well, obviously, we have to be able to fit the flowers, so the flowers are going to have to go over here. These are flowers. And then the last one is the pavers. And we have 42 feet of pavers. So again, our pavers would go here. Now I'm going to scroll down to the bottom, and we're going to see how we would have shaded this. It told us in here that we were going to use orange here, and that was, or brown, whatever you want to call it. So our pavers, our mulch was orange. Our grass was green. That was grass up here. Our flowers were pink or purple, whatever color you want to call that. And then our pavers go down here, and that's black. And really, all you had to do was that. You didn't have to give me much more color than that, just so I knew what color you wanted each section to be.